Hello, everyone. Welcome back to a special edition of the .NET and AI because we have a birthday today. It's not a person birthday, it's a technology framework or whatever. So, hey, thanks everyone from Brazil, Israel, Brazil, Pakistan, Spain, India, Texas, here, Canada, and more. I'm super happy today because I'm here with my friend Rodrigo. I'm going to ask him to introduce himself, but first, you always told me that I need to introduce myself. So, hey, Bruno here, part of the Cloud Advocate team, super fan of AI.net and more. And hey, who is our guest today? Do you want to introduce yourself, Rodrigo, please?
Thank you. Hello, everyone. My name is Rodrigo. I later have a slide to present myself later on in this presentation. Thank you, Bruno, for having me in this session. And hello, everyone from India, from Brazil, from everywhere. And I'm very, very excited to be here and to talk about technology. As Bruno, I'm very fan of artificial intelligence, of coding. I love to code. I've been coding like since I'm 6 years old. So
Yes, and hey, today, I am going to be super honest with all of you. When we booked this, I didn't realize that we said, okay, what we can do? I want to talk about semantic kernel and everything else. And I didn't even realize that today, literally, it's the
the
anniversary of the
anniversary.
official release of that. Rodrigo said to me, hey, December 18th, this is the date, which is super cool and more. And I know that people love the code. So if you want, Rodrigo, I will share your screen and let's start to
Yeah,
talk about
please
this
go ahead.
because the main idea today, just to set up the context, is we are going to talk about .NET, AI, and semantic kernel. And we know semantic kernel supports other languages, Python, Java, and other
Exactly.
stuff. But today, let's talk about how we get there, what our experiences, and we're also going to talk a little about the couple of cool new things that we have right now in semantic kernel.
Exactly.
So you have the screens for you, and thanks. Oh my God, you did a super cool intro. As usual, I didn't prepare for this. So this is the first time for me also looking at Rodrigo stuff here.
So I work at Encamino, right? It's a company here in Spain, and they have like a motto that says "We think in colors." And I actually feel very committed to that motto because usually when I create my own presentation, my own PowerPoint decks, I do a lot of colors and I do a lot of movement, a lot of animations, and it's true that when you know what you are talking about, you do not need a presentation. But somehow, I usually like to have something to show to people, and I usually create this kind of stuff. So again, Bruno, thanks for having me. I prepared this small slide to present myself. As I already told you, I'm super fan of .NET. I think that I've been coding all my life since I'm 6 years old. I started with something called Basic. Do not confuse with Visual Basic, something pretty old. And I've been using .NET almost from the beginning. I remember the Visual Studio .NET and the first version of CSharp and so on. And in the last years, I've been working with artificial intelligence, especially generative artificial intelligence. And before that, I was working with the do you remember, Bruno, the Q&A maker, the Louis, and this other stuff that in that
Yes,
time, cognitive services. We were not so fond of using artificial intelligence that lightly like today, right?
it seems like it's something old or whatever, and it was 2 years old. It was 2 years
Exactly.
ago. I'm sorry about that. By the way, before jumping here, hello Edmond for Georgia and Dot Morten asked a question. Is 5.4 supported the semantic kernel? I want to
Oh,
say
that's
yes.
a good
I
question.
know that it's already available in Azure. In Azure, I tried to deploy I don't remember if it was an internal version or more, but it's not a serverless version. It was the one that runs in the VM, and that one is expensive for me and my team. So I waited there. I am going to try while we are talking to deploy one, but as far as I understand, it's going to say yes because 5.3, 5.3.5 all of the five models on the five family support the chat completion schema. I'm guessing that 5.4 is the same. So once you can deploy it, it should be the same as the other. But again, not 100% sure. So thanks for the question, Morten. And we go back there. Sorry, Rodrigo.
No,
I
no,
like
go
to try
ahead.
to engage
This
with
is
the
a
audience and
conversation, and
answer
I
questions
really
as possible.
appreciate if people ask questions because that drives the conversation further. I have something prepared, but we can change the script, right? That's the idea. And about it's going to work because they haven't changed the interface. Okay, so as soon as you have deployed that, actually, I'm expecting the people from Olama to have a copy to use it locally, but you can have it in the AI Foundry, and it's going to work because the interface is the same. It hasn't changed. Okay, so it's going to route you to a different model deployment in the cloud. So just to finish the presentation part, I have a YouTube channel and a blog. I usually share there weird stuff that I found using technology. So I'm not regular publishing things, but when I publish something there is because I know it's hard to find on the internet, and I would like to share with people those secrets that we uncover. So in this session, I prepare code. So by the end of the session, I would like to show you an example of what is the latest things that we are doing with Semantic Kernel. But if the people here don't want to wait till the end, you can scan that QR or just see the link there. And that's going to take you to my GitHub repo where I have the code that we are going to use now. And also, Bruno and I have prepared a collection of links of everything that we are going to talk here. And you have there the QR again for scan that, or you have there the link. Okay, that's all the resources that has information of what we are going to talk about today. So, semantic kernel. It's been a year, more than a year, and I would
Yeah.
like to do a walkthrough for using it. I've been like in around 10, 15 projects, and in every project I have to use semantic kernel. And there have been some happy and joyful moments, and others not so much. So let's start with what you already said. Today, a year ago, we got the first version of semantic kernel, the first 1.0 version, the general availability. Before that, we have like multiple. Yeah, I'm very.
That's the ugly logo. Not the ugly logo. That's the we have a new and amazing
the
logo
first one.
now. But yes, that's the old one. I forgot about that.
Yeah, I have a slide to talk about the logo because it was a crazy stuff. We have even a logo that had Clipo in it. Remember, it was Clipo, and the hand became the SK.
Yes. But we can't use Clipo. There is a full story there about that. But yes, and hey, going back here, as Rodrigo mentioned, this was presented 1.5 years ago. I think it was in Build or somewhere. I can't remember.
Yeah.
Kind of the preview version. Then 1 year ago, make GA with different support of different languages. And in the meantime, if you are a semantic kernel user or not, one of the challenges that we have is that the interfaces changes a lot. So probably something that you wrote, you code, I would say April this year, is not going to work today. Not it's not going to work, but you need to go and update the code, update to the latest version and update the code and more. And it also makes sense because semantic kernel somehow will follow also the deploy of services that we have in Azure. In example, the deploy of technologies who were more and more popular, like RAG and more. So yes, it's been a year. But if we think back, and I love this slide, as a product, is literally a year and a half or a little more. Probably, I don't know,
Exactly.
17, 18, 20 months, something like this.
Exactly. And as you said, we were in my company. We have a joke. We said that semantic kernel was like LangChain, not only because it was trying to do more or less the same, but because every time you update the version, your code was completely broken.
Yes.
It was like so. I would like to share something with the audience. There is a library that is open source, completely open source, so it's an open party for everyone. Anyone can use it, can collaborate, can create issues. It's called En Marcha. En Marcha in Spanish is on word, okay? And it's an open source library where my team and I were creating all set of stuff to somehow use semantic kernel, but don't worry that much when semantic kernel was being updated, okay? To survive those updates in those moments, okay? So, and here we have a lot of knowledge to work with different projects and to work with a lot of stuff, okay? So everyone is invited to see here to say, oh, I don't think this is a good idea, or you know what, this is a good idea, let me have it. Okay. And we create this stuff to protect ourselves with all those changes that Semantic Kernel had. But I would say that right now it's a very established interface.
Yes.
I don't see any changes. I think that is a very robust solution to create projects that require integration with artificial intelligence, right?
Yes, and wait. Oh, there it is. So we have go there because literally you have Raj asking a 30 seconds overview of what is semantic kernels, and you have it there. And it's an SDK, it's a framework, a toolbox, whatever. They used to have an extension for Visual Studio Code, but the idea is that semantic kernel is for us as .NET developers, in example, is an SDK that allows us to interact with models. Like initially was OpenAI model, like the GPT, but now we have also Llama or 5.4, like Dot Morten was asking, to interact with large language model and small language model, and also with other services. And at the end of the day, what I want to see, what I want to explain today, that is a set of features that allows you to talk with models, in example, but allows you to work with vector databases, allows you to work with agents, processes, and more. So everything new that's coming to the AI world somehow fits into the semantic kernel, and when the time passes, it's going to be part of the core, or maybe they put it away, because we don't have planners anymore, in example. But think about this. It's an SDK to do AI in .NET. What do you think? Anything that you want to add on top of that, Rodrigo?
For me, semantic kernel is just the toolkit that it allows you to integrate with something else that is around artificial intelligence. So it's like, okay, I need to use Olama, or I need to use Onyx, or I need to use this weird artificial intelligence model that I will deploy on a virtual machine, but I want my code to be agnostic to those elements. Okay. So I want my code to survive the changes that
Yes.
comes with these technologies. And semantic kernel has provided that. It's allowing us to create code, services, applications that we can switch a memory for the other memory, and it's going to be transparent for the rest of the code base. We can switch models, and it's going to be transparent for the web application. You and I have some examples that we have the very same retrieval augmented generation application that uses OpenAI, but then we switch to Mistral, and the rest of the code is the same. Perhaps the results are going to be better or worse. That depends of the AI model, but the code is the same, and that is very important. Okay, and I think that semantic kernel has helped us to get to that part, to create awesome applications that if we need to change them, it's not going to be so painful.
Yes, and in example, let me show a very basically the hello world of semantic kernel. Let me share my screen so people, if you like to see some code,
What you're
this
sharing, there's someone asking that I think it's Dot Morton says, I would like 5, 3, and 4 to have function calling. And it's true. The 5 family models do not have function calling on their own, but there's people in Hugging Face that have created quantifications or fine tunings of the 5 models that provide function calling. So if you are curious, go to Hugging Face, search for Phi with function calling support, and you're going to find some very interesting models that are 5 family models that support function calling.
Yes, and hey, let me give you a quick overview of the chat. And by the way, this is kind of something that we want to start to promote, but in the second half of January, we are going to release a repository that is called Generative AI for .NET developers, and this has a lot of, it's focused on samples, not in theory, of how you can do this. And this is one of the samples that we have because we cover chat, vision, and more. So ABC of semantic kernel. I'm working with Olama. I have a model here. Locally, I have the Llama 3.2 vision. So I'm going to have, because we have a new library here to work with semantic kernel connectors, I have Olama here and semantic kernel. And once I have that, I will create a history, and I will have a while true loop that is going to ask question and answer question, ask question and answer question. That's it. You can even do this with 10 lines less of code or 20 lines, and that's going to work. But this is it. you are going to change A for B here, and it works. And in example, if you want to use function calling, which is basically what .NET is asking right now, is again creates the example. In this scenario, the example is using GitHub models, so everybody can try and test this. And I am going to use one of the models available, which is the GPT-4o Mini. And somewhere here I have defined a plugin, which is a function here, is one of the ways to use functions with semantic kernel. And going back to the question from .NET Martin about plugins, I don't know if i4 supports plugins. It's not. I probably need to ask the team about that. But it's in the top request features for the Microsoft Research team. So the 5 models support function calling. And the whole idea of function calling, and semantic kernel make it very easy, is that you basically inject into your kernel definition, into your program definition, you inject something like say, hey, if someone in part of the chat, in example, mentioned that they want to need the temperature in a city, there is a function here that can answer that. And that function is literally your code. It can be connected to your databases, to your systems, and more. And semantic kernel make this happen in a very, very easy way. When I compare this to other frameworks that I know, it's super easy to do here. And there are other things that we are going to show later, if we have time with Rodrigo, that can also help for this. But think about these kind of things. Semantic kernel is a framework that allows you to do AI. That's it, connected to services, models, and more.
And I was saying 5.3 and 5.4 does not support function calling, but there are versions that people have fine-tuned in Hugging Face that still are 5-type model AIs that support function calling. Okay, so the one provided out of the box by Microsoft does not, as you say, is one of the top requests because it's a really nice model. But you can find in Hugging Face people that provide custom implementations with function calling support. So let's go in. We have to change the way we code. And I think that semantic kernel is actually helping us to do this. You show the code yourself, right? So we go from what we call the syntax way of working, that everything you think about, you have to code. You have to create someone asks you to do something, and you are thinking about classes, you are thinking about types, you are thinking about if then else, for loops, etc., right? And with semantic kernel, we find out that it is helping us to move forward into what we call the semantic way of working. That is actually, yes, you are still going to write some code, but most of the time, what you are going to do is use a library to ask a model to do something. And based on what the model responds, perhaps the model itself is going to do something else. So we are changing the way we need to think and the way we need to code from thinking in loops, if then else, etc., in thinking about prompts, in thinking about which model is going to help me do something. And our code is going to become more like a story that we tell, and less than a code that only few people would understand. And there's also an idea that eventually in the future, we will stop coding at all. I don't think that code is going to disappear, but the way we interact with IDEs and the way we interact with programming language is going to be very, very different as it is today. And semantic kernel is just the first step to that. It's the first way we are doing this. This is still code. We still program a lot, but we are seeing that we are writing more stories and we are writing more prompts rather than if then else and for loops. Okay. And with semantic kernel, we are learning that. We're learning to focus more on the semantic part of what we are doing and less on the structure and syntactic part of that. And we can do that with very ease using different models. And that has helped us in this year, for example, to create very complex RAG applications, retrieval augmented generation applications. It has helped us to create awesome chatbots. And now, in the last few months, we are starting to create amazing copilots, this evolution of the chatbots, right? And semantic kernel is being in the center of all of this. So changing the way we code, let's talk about some dates. Okay, today is the anniversary of the general availability of the .NET version. But in April 25th, we hit the 1 million downloads for the .NET library, unique downloads. Okay, so in less than a quarter of the general availability, 1 million different projects were using the .NET version. And by May the 22nd, it was announced that the Java and Python versions were also in their first 1.0 version. And in less than a few months, the Python flavor of the semantic kernel reached the million downloads. Unique, distinct million downloads. So we can see here how this library, this framework, became very popular very fast, and is allowing us to create really amazing things. Okay, so in my experience, I haven't seen a framework to be so easily adopted and so fast like has happened with semantic kernel. And part of the secret sauce is the fact that it's not only in .NET, it's also in Java and Python. And in Python is a very important language in terms of artificial intelligence. Okay. And then came the logo, our beautiful logo created with Microsoft Paint and using Lucida's handwriting font, right? And we'll live with this. But eventually we got this logo, something that looks modern, it looks pretty amazing, and nobody understands. Do you remember what they told about this logo?
No, I remember the blog post. I remember a couple of, I think they talk about in the office hours and more. I remember I told, but I said, okay, it's in my point of view, and this is very personal. It's like whatever, some colors. It's nicer than the previous one, but that's it. I like
So
this
the
one
idea-
better than the old one, yes, but I don't feel very.
It's
whatever.
better than the old one, definitely. It's better than the old one. And it actually looks to be the focus point where many things join, right? That's the idea of semantic kernel, is to be the center of a lot of things, very different things, and everyone converge to the center. Teamwork, different technologies, Python, Java, .NET, different databases, different AI models, etc. So the idea of them is to be like a whirlpool, that everything goes in the center to produce something amazing, and it's a very powerful force. But yes, we got this logo, and some people love it, some people hate it. I think it's nice. It's better than the old one, right? So what happens with semantic kernel? So semantic kernel evolved from three pieces that were plugins, planners, and people, and a lot of things around create your plugins, think about the user, use planners to automate, etc. And it now looks like this. It looks like you have your code, you have plugins that come from somewhere else, you have hooks and filters and things to attach to, and then you have a lot of things happen in the lower part that are different AI models and different ways of working with AI technologies. And as I said, the logo represents this whirlpool that attracts everything to the center. So now semantic kernel helps to connect different kinds of code with plugins that come from different sources, with hooks and filters that we can create to attach to those processes, and to easy change the AI models that we use without suffering that much in our code level, right? So it became like this huge galaxy of technology that works around artificial intelligence. But then there is a road in artificial intelligence, and I think that you have seen this image before, right?
Yes, and hey, I literally published, I think it was yesterday or a couple of days ago, an article where I think a month ago or 3 weeks ago, Luis, a colleague here, write a little about vector stores and semantic kernel. So, but a lot of people ask, okay, can you give me real samples? I'm going to share the link in the chat, and I write an article which is basically talk about how you can use writing a new RAG using Quadrant and Azure AI Search with semantic kernel and Microsoft extensions. And I did a session about Copilot. This is what we have today. And we talk a lot, and we are aiming to the future autonomous agents or assistant. I still name things the way that I learned it. So if I say assistant, it is agents. Sorry. If I say agent, it is assistant. Sorry. But yes, there is a path here. And as we joked before, I don't know if we would joke on camera or before camera. In example, we lost planners, which I like planners. They were a nice feature. I did a couple of very interesting things with planners, but we have other stuff here. I'm not sure where you go. As I said, this is the first time looking at the slides. But I am
really?
Going to do a vanilla
you haven't seen this image before? Really? Okay, so thinking about this image, where do you think we are right now? Do you think that we are in the chatbot area, RAG area, Copilot, fully autonomous? Where do you think we are right now in terms of artificial intelligence in the landscape that we are
I will
creating?
say closer to the fully autonomous than the chatbot. That for sure.
Okay, how much close? Very close? Not that much?
I learned how to do Copilot for Microsoft 365 a month ago, and oh my god, I mean, if you have the license to run Microsoft Copilot, it's not very tricky. And of course, use Semantic Kernel as the glue to connect services together. But creating your own Copilots with your own data, services, and more, it's not as tricky as I think. So I'm guessing that Copilot is check, and in fully autonomous, I will basically try to first define which is fully and also try to define which is autonomous. See, because if I want to have an agent that automatically sync the time of my computer and 20 other computers, we already have that. But depending on the complexity of the agent, that can be a tricky question. But I will say close to the fully autonomous than the chatbot, that for sure.
Awesome. So you were absolutely right. We consider this is something that we can say it's open to opinion, but we are thinking that we are right here. I think that if 2024 was the year when we create a lot of chatbots, copilots, and retrieval augmented generation applications, I think that 2025 is going to be the year where we are going to reach fully autonomous agents, when we finally are going to create process that with one single human stimuli, or not a human stimuli, but something that happens in the business environment, is going to start creating process and start to addressing issues or problems or whatever that right now is done by people. Okay, that is going to offload these tedious tasks from people and are going to be automated by agents. And only if something goes wrong, they are going to ask for a human intervention. So right now we are in this part. And how do we get to this part? So first, we need to understand that agents can be very simple, like I go search an information for you and I return that information to you, or very advanced. These are the autonomous agents, the ones that dynamically do things like a human being would do, and then they inform you about the result or not. They're completely independent. Okay, it's transparent for you what's going on besides the result for your business process. And we need to understand the architecture of an agent. So we need to understand that there are going to be foundational models. These are the OpenAI, the Phi3, Mistral, whatever. These are the models that provide the generative artificial intelligence functionalities and capacities. We need an orchestrator. Here is where semantic kernel comes into picture. We need to have knowledge, skills, and autonomy planners and things like that. Also, part of this is provided by semantic kernel. And optionally, we could have a user experience layer, a part where the user could request things, or a part where the user could obtain information. Okay, and also we can have other agents. So one agent could talk with another agent and another and another and another. But in high level design, this is going to be the architecture that we are going to work with. And we need frameworks and we need libraries that can help us create all these different pieces. Semantic kernel is not going to work at the user experience level. That's clear. We have other tools that are much better to do that. But it's going to work at orchestration level, skills level, autonomy level, and the communication between agents, as we are going to see in the demo that I had prepared. Okay? And then comes the planners. You love planners. You really love planners.
I mean, they solve the problem. They solve a problem in an easy way. And I like that. I like to have that 10 lines of code that using all of the context with the large language model can connect A, B, and C and send data and orchestrate everything there. So I like the idea and I like the implementation. That said, in my experience, they only work well when you have access to the powerful models. That's it. And also the plan per se. I tried to do some very, not complex, but long plans, and they got tricky and sticky there. But if you kind of know where you are in the sentence, okay, this is something that planners can do it. For me, it works great. But again, it was kind of slow and whatever. There was a couple of room for improvement pieces here and there, but I like it and I like the idea. But once we are talking about agents and more, I know that this kind of evolution of the planners makes more sense because we use the full spectrum of capabilities that we have. But yes, I like it.
So the thing with planners is that it's something that we have since the beginning of semantic kernel. It's one of the strong things that it provide. Okay, and indeed, with a few lines of code, really a few lines of code, you could create very complex procedures that the artificial intelligence were doing for you. And as you said, the problem is that they were slow, okay, and expensive. Because, for example, we have very complex planners like the stepwise function calling planner that was talking a lot between your code and the LLM and was burning tokens like crazy to do some stuff. And the thing was that they were very, very slow. So, for instance, if you were creating some user experience in Teams, for example, Microsoft Teams, it has a timeout. It has a 100 seconds timeout. And were doing some very complex business operation with planners, and we were receiving timeouts all the time because the planners were taking too much time to create the result, and Teams was timing out. Okay, so we start doing very weird things like, okay, we create the plan with GPT-4, but we execute the plan with GPT 3.5 because it's faster. So we start to do things that were not really that good. And the people in semantic kernel noticed that the AI models were becoming better, especially when combined with function calling, in creating their own plans. So if you provide a very good system prompt, and if you provide a good description of functions for the artificial intelligence to call, it was the model, especially GPT-4o or the O1, were very powerful to create their own plans. So planners became not that much a good idea. And in fact, now that we have these very powerful models, plans became irrelevant. And also because right now we can create functions from stuff that companies already have. So, for example, if my company has a very powerful REST API, using semantic kernel, if that API has a well descriptive swagger, I can import that swagger into semantic kernel as semantic functions. And semantic kernel is going to inform to a large language model, hey, you know what? You have these functions to call. But these functions to call are actually API calls that are going to call my API resources to do a stuff. So it's a new improvement in what we called long ago the API economy. So we can start reusing our APIs in a different way, providing them as functions for the LLMs, using this function calling, using these capabilities that this advanced model has to create its own plan using semantic kernel. Now, we no longer use planners, that's true, for dynamic scenarios, but sometimes we may need baked plans. Okay, I have like a set of steps that I would like to use or I want to reuse. In that case, we still have a planner inside semantic kernel, and it's called the handlebars planner, which uses a notation called handlebars that is kind of like it's like markdown, but it's not markdown, okay, because it supports loops, it supports decision making with if sentences, etc. So if you need a planner and you want to bake your plan, you can use this one. Otherwise, just keep going and provide all the functions to LLM, and it's going to work perfectly and flawlessly. And also in Spanish, because my content is created in Spanish, I have a video about what happened when semantic kernel decided to kill all the planners, and with a new logo this time. Okay, so we have them, but we do not really need them. So what is the new way of creating all this? And we are now going to the future. This session was what's new, what's cool, what's coming in the next year. So I was saying 2024 was copilots, chatbots, RAG applications. I think that 2025 is going to be about agents and process. So now in semantic kernel, and it's in experimental phase, like almost everything in semantic kernel, we have two new frameworks inside. One is called the agents framework, and the other one is called the process framework. So have you worked with these ones, Bruno, or the audience knows about these ones?
I only did the hello worlds. I haven't used them. I need to pick up a couple of samples and make them work with this to make them part of a real solution. But no, only read about this and did the hello world, and they are amazing, literally. And basically, I am asked a question and he answered himself. And if we saw a little code, a couple of code before we finish, it will be great to answer this. That he mentioned that planners could be used to implement function kernels, function calling when the model not support function calling. And yes, it's not that, but yes. I mean, I won't put that as an official statement, whatever, but in the Bruno side, I would say yes, can help you get there because it's kind of evolution. So yes, sorry, I like to add that note.
No, but it's a nice idea. Yes, with some effort, lots of effort, you can make function calling using a planner, but what actually you are going to do is like the model has to tell you which function to call. So
Yes.
you are going to receive that, and you are the one accountable for doing the calling. Okay, but yeah, it's feasible, it's doable, right? Okay, so agents framework, process framework. Agents framework is a crazy idea. It was introduced actually by the people at OpenAI. They call it assistance framework. Okay, it's the same, agent assistance, and it's the idea that how can I using prompts, how can I using natural language and just a few elements of syntactic code, the old way of coding, how can I create something that is autonomous, that given a stimuli, given an instruction, an input, it can do some work alone without human interaction and provide a response, but also how the agent can talk to another agent and another and another and so on to fulfill a goal requested by a user. So the agents framework is a framework inside semantic kernel that is going to allow us to create these agents, to create these entities, and how and to control the communication between with entities. And as you are going to see in the demo in a few minutes, this communication is controlled with a prompt. We do not need to create code, to a specific code, to control this interaction between the agents. And then we have the process framework. So the process framework is the newest one, and the idea is, okay, so companies, organizations, they have their workflows, they have their business process, and they have already defined those processes in different steps. What if we can take those workflows and inject artificial intelligence in some parts of it? What if part of these steps inside the workflow could be done by agents? And what if we can control that using an LLM in a very easy way? So the idea of the process framework in semantic kernel is to introduce artificial intelligence into the business process and the workflow process that we usually code in a different way, including agents and anything else that we have been doing so far. So, because this is very cool, I would like to do a demo here. Okay, so I will switch to Visual Studio, and I hope it looks in a good size, or I could provide a bit more
zoom
of
a little. Yes, perfect.
Like this. Okay, so what are we going to build here? So I like a lot marketing. I think that marketing is a very nice career. It has a lot of things. It has technical stuff, it has creative stuff, it has a lot. So I decided to create a small marketing agency here. So the idea is that someone, a customer, has a weird idea and is going to provide that weird idea as usually customers does. With very few words and very cryptic way. So we are going to provide a slight idea to this creative company, and this creative company is going to use agents. One agent is going to be the manager, the one that is going to control all the process for the creative agency to create a copy and an image for the idea of the customer. Then we are also going to have a second agent that is going to be the creative director, the one that is going to judge the result and is going to tell if it's going to be to satisfy the customer or not and request changes. And we are going to have another agent that is going to be a copywriter. The copywriter is the person that is going to create the slogan or the phrase or whatever that is going to satisfy the marketing idea the customer has requested. So the manager is going to delegate into the copywriter to create the copy. The creative director is going to receive the copy and is going to say, okay, this is okay, it's approved or not, and is going to provide insights about what is need to be changed. So the copy is going to get the message from the creative director, create a new copy, go back to the creative director, and so on until the creative director says, this is approved, this works. And then the manager is going to take the copy, send that to the art director, who is going to create the image that we are going to also use with the copy. And all this is a process. So it has a start point, it's going to have a loop in a moment, then it's going to have an exit. Okay, it's like the common graph that we usually see. Okay, and we are going to use elements that we already use in semantic kernel, and we are going to use agents. And as you can see, the code, let me take this away, the code is text. I'm not actually writing code, I'm just creating strings. I'm giving a name to the manager, I'm creating the instructions for the manager, I'm creating how the manager has to summarize the instructions if the context grow too much. But I'm saying that in text. I'm not creating code to map reduce the context that we are sending. I'm creating the instruction for a creative director. I'm saying the creative director needs to interact with a copywriter, and I have the copywriter. And as you can see right now, everything is just plain text. That's it. Okay. So now comes the code. So I will have a chat history. That's it. This comes from Semantic Kernel. It's a library that is actually a repository of the different interactions that we already have between the assistant, the artificial intelligence, and the user. The rest is actually boilerplate to read variables from the app setting JSON. Here, I have the configuration of the semantic kernel. So in semantic kernel, and if you have used the library, we already do this. We are creating a semantic kernel instance, and we are adding support, in this case, for Azure OpenAI for the chat completion and the image creation, the text to image creation using DALL-E 3 from an Azure OpenAI instance. Then we are going to set up agents. Okay, so this setup agents is where I'm going to create all these different agents. So the first agent that I'm going to create is going to be the manager, but then I'm going to set up a group chat. The manager is going to be one of the agents, but then the other agents need to be in a group chat. Like, okay, I will put in the same room these people to interact between them. Okay. How do we create an agent using semantic kernel agent framework? Well, it's really hard to do so. We only need to create an instance of chat completion agent, give it a name, give the instruction, provide an instance of the kernel, and this is not required. This is an experiment I was trying to do before this session, okay? With these few lines of code, I have created an agent. That's it. Name, instructions, and the kernel with all the features that this agent is going to need. So going back, I'm creating the manager agent, and then I'm going to set up the group chat. The group chat is going to have two agents. One is going to be the creative director. The other one is going to be the agent copywriter. But now I need to tell the rules on how these two guys are going to talk. Who comes first? Who comes second? And things like that. And when the conversation is over. So remember, we are going from syntaxes to semantic. So all these instructions are going to be provided using natural language. So as you can see here, I have something called the selection function. The selection function is going to be a strategy provided in natural language for the LLM to know which agent should go first, then second, then third. In this case, I only have two agents, but if I have 3, 4, 5 agents, I can set up here the rules for the interaction between them. And I do that in natural language. Once again, there is no an if then else, there is no for loop, just telling them how things are going to work. And then I just say, who are the participants? And then I say the rules. Who comes first? Who comes after? That's it. And finally, I'm providing the history of the current conversation. This history is going to be changed using what is called a reducer. A reducer is nothing else than a strategy to summarize the context, because you know that the context is limited. So far, this is the code that rules the interaction. And then we also need something that is called a termination. A termination function. This is going to tell us when this group chat should finish, when the meeting is over. Okay, and we said that the meeting is going to be over once we respond to yes, this has finished. We have what we have trying to do. And as well, we're going to have the history that we need to deal with. Okay? Now, this history requires a reducer. In this case, we are going to use code, a very complex code provided by Semantic Kernel, called the truncation reducer. That is going to be.
I am going to ask about that. This kind on the chat history truncation reducer is part of the SDK, yes?
Yes, that's part of the SDK. I'm just saying here how much I want to get. I just want to get the last part that has been talked to.
Perfect.
But because it's part of Semantic Kernel, it's part of the agent framework. Okay? So as you can see, all this stuff that is very complex became just one line of code. Okay? Then, well, I will create the chat. So here we have the group chat where we have the selection strategy, the termination strategy. We said who is going to be the first agent to work. It's going to be the copywriter. We said which agents are going to stop things. In this case, only the creative director. We tell the name of the history variable. That is the one that we are defining here. Okay, here and here. Okay, and finally, we are providing the reducer strategy that we have defined here to reduce the size of the history. And that's it. Now we have two agents in a chat group. They are going to interact. We provide the rules for the interaction using natural language. We are providing the rules to terminate the interaction in natural language, and we put them all together in these lines of code. Okay, the rest of the things is boilerplate that is part of the agent framework, and we can read about this in the documentation. It's pretty good documentation. Okay, now with that done, the next part that we need to do is create the process. Okay, we have the kernel, we have added the agents into the kernel. Now we need to create the process. This is the process framework. The process, to create a process, we only need to call this instruction. Okay, setup agent and process, and give it a name. Okay, this is a method that I have created here that is going to create the process. To create a process, we only need to do this. We only need to do this class, process builder. This is part of Semantic Kernel process framework, and here we provide the name that we define over there. And then we are going to use some steps, okay? Because all process is a set of steps. So what is a step? A step could be something as simple as the welcome step that is going to print a welcome message. All steps inherit from this class, kernel process step, okay? That's pretty much it. And we define what the process does as kernel functions. If you remember Semantic Kernel, define kernel function as plugins, are the function callings that we provide to a LLM to know what to do. So we're using the LLM as a planner to call the different elements of the process that we are going to define. Okay? So this one is going to print the welcome message, but we could do more complex stuff, like, for example, the manager agent step, which has 3 functions. Okay, let me collapse something. Okay, so it's going to have an invoke agent async. This is the one that is going to call an agent to start working. It's going to invoke the group async. This is the one that is going to call that group chat where we have the copywriter and the creative director. And finally, how we are going to handle when we have a response from the group chat. Okay, what we are going to do once we have the response from the group chat. And each one of these is just a function that the LLM can call if it knows that these functions exist. Okay, now we have these steps. Now we need to define the graph that these steps are going to work. So this part here, attach error steps. This is only a boilerplate that I do, that if something goes wrong in a step, I can print that on screen so I can debug my code. Okay, but you can read this in detail if you clone this code from the GitHub repository. The important part is to understand that this is the process is a graph. Therefore, it has an entry point. That entry point is here. And we said, okay, the process that we have defined is going to start with an event called a start process. And that event should go to the welcome step. The welcome step, on the other hand, is going to use a function that it's going to have a function result that is called welcome message. And that's going to be sent to another step that is called the user input step to this function, get user input. If I go to the user input, it's a very simple step. We can see that I have here the get user input function. And this, the only thing does is print a message in the console, and it's going to request us for some information. The human has to provide something. In this case, the marketing idea that want to be developed. Okay. Going further, the user input is going to produce an event, and this event is going to be handled by the manage agent step. This step can receive events because the process framework is event driven. So we are saying that in case the event is agent response, this is going to send that result to the render message step. This is the one that is going to print in the console all that is going on to this function, render message. And it's going to say the name of the parameter that should receive all this. The parameters are always object, and the process framework is going to take care of casting the object to the proper type. In this case, if we go to the render message step and we go to that render function, is this one here, render user or render message here, you can see that the object is called chat message content, okay, which comes from Semantic Kernel. It's part of the Semantic Kernel library. This is not agent, not process. This is pure Semantic Kernel, okay? And as you can see here, oh, I'm sorry. I'm sending that as the parameter message. So in this way, this is going to be able to know that that is the method, that is the function that should be called, okay? So we have a lot of steps here for the manager to manage all the interactions with the user and all the interaction with the agents. But eventually, we have the agent group step, that is the chat room, where we have the creative director and the copywriter, and they are also going to interact between them. Once that interaction is finished, that is group completed, during that interaction, we create group message to print in the console the conversation between the copywriter and the creative director. But once they have finished, we are producing this event, group completed. And we said that once that's finished, we have a copy. And we are going to send that copy to a different element. That is the image creator. So the image creator is not going to be an agent. The image creator is going to be plain old semantic kernel code. Is the code where we take the kernel, we request a service, in this case, the text to image, we generate the image, and we produce a result. So how does the process framework emit all these events? Well, in a very, very hard way. You only need to call this class emit event async, where you give the name of the event that you want to produce. When this is emitted, the process framework is going to get this, and it's going to take the configuration that we have here, and it's going to see which step can receive that event. In this case, we're seeing that the image created is going to be sent to the manage agent step saying receive response. So the manager agent step can provide us with the complete copy and the image. It's very, very simple. It's extremely simple.
Rodrigo, question, because we need to wrap up in a couple of minutes, and there is someone asking if we can have access to the code, if we can have access to the repo.
Yes.
I will say that check also the semantic kernel samples, because I saw a very similar one in the semantic kernel repo. Oh, there it is. So otherwise, it's in part of the resources in the video. If you take a look at the resources of the YouTube video, you will see that we have a collection, and the collection is there, and there it is. So the collection is there. So you want to give it a try for a run?
Yeah, give me an idea. Crazy.
I don't know. Idea. To have a house that can host kittens in the summer. Something like this. And we have Switch asking here in the meantime, how many agents can be in a group chat? That's a good question. I don't know if we have a number here, but I will say
there's no limit. There's no limit at all.
I would say give it a try, but if you put a lot of stuff there, also get ready to have some weird memory limits or whatever, because yes, or going to be slow or more, and you need to define a lot of rules also for that. So emotional, hitting up, foster a kitten, be their hero. Oh, that's super cool. The manager
is still thinking.
Yes.
It finished. It says, okay, so the copy is going to be something like summer's heating up. Not very much, but let's see the image. Okay, so we went from kittens to something that looks like Ernest Hemingway,
Yeah.
I guess. Let's try a different idea. I have some crazy idea here. Like, what about nails polish from snail's goo? Yep. So it's starting to work. And as this is working, you can see here that it takes the message of the user. You can see here the copywriter thinking about an idea, the director actually antagonizing the idea, but asking for changes, the copywriter creating one, and so on. Okay. And the same we have here. Okay. So it came pretty fast with the idea. Let's see the image. Okay.
And by the
Here's
way,
the image.
hey, this is much more better. And I like it.
Yeah, it is.
And I am going to also share that what I like about this, that if you, in example, you are using right now DALL-E 3 to generate the images, I think we quickly see something like that. But if you want to use other models, other services, if you want to use other stable diffusion, whatever, to generate the images, in example, or connect a kernel system, this is a great way to do this because they can literally be isolated. Each agent has their own domain.
Exactly.
These kind of things. Sarah's asking for the code again. Please check the resources on the video because we have everything there. And we are almost at the end of the hour, Rodrigo, so I will go back here, invite everyone to check the resources. We have everything there. Thanks a lot. This was amazing. As I said, I read about the new features, but I did my Hello World, which was a very vanilla version. Yours is much more real. I like it because marketing agents really set this down, and I love it. Thanks a lot.
Thank you, Bruno. I will also share the link in the comments as one of the users in YouTube. Okay, so people can copy or click it. Okay, and man, thank you for having me in your sessions. Really, I'm very, very happy, and I hope that you have enjoyed the slides and the code and everything.
No, thanks to you for coming here. Thanks to everyone. Happy holidays, everyone, and see you
Happy
all
holidays.
Goodbye.
Bye-bye.